Hi, I'm Chuck McLennan. This Know-How is the 7th program in the Drivability series. We'll be going over some drivability information on 1991 5-liter, 1992 and 93 5.7-liter throttle body engines, and 1994 and 95 5.7-liter fuel-injected engines. I went straight to the experts for the drivability information in this program. Brian View from the San Francisco zone has developed 2 diagnostic approaches that I will go over today. Bill Fisher from the Greater Atlantic Zone has come up with a list of tips and things to look for when diagnosing specific drivability conditions on Roadmasters.
Hi, Chuck.
Welcome, Bill. And Dave Miller from the Orlando Zone will answer some of your drivability questions taken from a recent Know-How questionnaire.
Chuck, why don't you go over the reference manual and talk about the road test and visual inspections while we finish getting set up over here?
Sounds good, Dave. Those of you familiar with our last drivability program will notice that this manual is set up in a similar fashion. The reference manual contains information on grounds, master wiring schematics, DLC information, diagnostic trouble code criteria information, and some valuable technical tips. The reference manual also includes an in-depth explanation of the inner workings of 1991 through 93 5-liter and 5.7-liter ECMs and the newer 5.7-liter PCMs. This information should help answer many of your questions regarding what really goes on inside this complicated box. The more insight you have into this, the better chance you will have of fixing every vehicle right the first time. The information contained in the reference manual and video comes from bulletins, service manual information, and the real-life experiences of Buick field and technical assistance personnel. Always road test the vehicle to verify the complaint before diagnosis. Remember, it's not a bad idea to have the customer accompany you on the road test. After the road test, perform a visual inspection. This visual inspection can save valuable diagnostic time, so always be sure to check that ECM or PCM grounds are clean, tight, and in their proper location. Be sure to check both grounds. I know the one back here by the distributor is hard to get to, but this is important. Check all vacuum hoses for splits, kinks, and proper connection. Check the ignition wires for cracking, hardness, proper routing, and tight connection to the distributor cap and plugs. Check the air intake ductwork for any collapsed or damaged areas, and make sure it's securely sealed at the throttle body. With the visual inspection complete, let's take a minute to talk about 2 drivability conditions you've probably heard of: spark knock and chuggle. To diagnose these conditions, we've developed 2 diagnostic approaches. One is for spark knock conditions, the other is for chuggle conditions. These 2 charts can be found in the Know-How reference manual. Both of these approaches were based on information from the service manual, service bulletins, as well as Buick field and technical assistance people. Let's start off with spark knock. Simply stated, spark knock is the sound created by certain types of abnormal combustion. This abnormal combustion can be caused by a variety of factors, such as a fuel mixture that's too lean, over-advanced spark timing, excessive coolant temperature, excessive intake air temperature, wrong heat range spark plugs, or higher than normal compression. Carbon deposits on piston and valve heads, as well as an inoperative EGR valve, can also promote spark knock. The diagnostic approach for spark knock begins with a road test to verify the symptom, followed by an under-the-hood visual inspection. The approach is then organized by engine model. The chart also refers you to an EGR functional test. This test checks for proper operation of the EGR valve. The EGR system is designed to lower combustion temperatures. Therefore, if the EGR system is malfunctioning, combustion temperatures would be higher and spark knock can occur. The chart also contains a knock sensor test. To test if the knock sensor is working, hook up the Tech1 and monitor the knock sensor. Now start the engine. And after warm-up, raise engine RPM above 1500. Now tap on the passenger side exhaust manifold. Tapping in this way should produce a knock signal and in turn retard timing. This one looks good. Let's look at the dual knock sensors on the newer 5.7-liter engine. On this vehicle, we see a knock signal while tapping on the right exhaust manifold, but not the left. This lets me know that there's a problem with the knock sensor or its wiring. Oh, and don't forget to refer to the diagnostic chart in the know-how reference manual, as well as the complete procedure in the shop manual. And just as a reminder, correct torque on the knock sensor is critical to its operation. Also, never use Teflon tape or other inappropriate sealers on knock sensor thread, as this will desensitize the sensor. Now, let's talk about chuggle. Chuggle, or surge as it's sometimes referred to, occurs at cruising speeds just after torque converter lockup, usually between 35 and 50 miles per hour. By locking the torque converter up as early as possible, very little slippage occurs. Therefore, you get a more efficient transfer of power from the engine to the transmission, resulting in increased fuel economy. However, during this speed range, the driveline is very sensitive to variations in engine torque. For instance, a slight power loss from one cylinder may only be felt during speed ranges just after TCC lockup. Anything that results in even the slightest weakness or miss will result in a chuggle condition. Even normal engine operation results in some detectable chuggle under TCC lockup. For these instances, a revised calibration is often released. Now, let's go over the diagnostic approach. The diagnostic approach begins with a road test to verify the symptom. While on the road test, it's a good idea to drive at speeds just above the torque converter lockup and see if the chuggle occurs. Sometimes it helps to drive at this speed on a slight grade. You should also have the Tech1 hooked up. Pay particular attention to TCC on-off status. The next step is to perform a visual inspection. Then it's a good idea to check for any bulletins related to the condition. You can use the DCS system or scan the bulletins in your dealership's reference booklets. Start out by checking base ignition timing. Remember, on 5.7-liter throttle body engines, you can reduce chuggle by setting base timing 5 degrees past top dead center. Now, let's test the ignition system for proper output voltage. You can use the ST125 spark tester for this. Remove the spark plugs from the cylinder heads. Check the plugs for any signs of carbon tracking, wear, cracks, or deposits. Remember, if a spark plug is found with an external carbon track, that particular plug wire should also be changed due to boot damage. If all these check out, it's also a good idea to check the plug gap. In some cases, you can reduce chuggle by decreasing the spark plug gap from, say, 60 thousandths down to 45 thousandths. Next, remove each spark plug wire one at a time and check for resistance. On older 5-liter and 5.7-liter engines, check wires from the plug end to the inside of the distributor cap terminal. This will help you catch any possible problems due to distributor cap corrosion. Also, replace any wire that has more than 30,000 ohms resistance. With the distributor cap removed, inspect the distributor, cap, and rotor for any signs of cracks, tracking, or wear. Also, check the bushing on the distributor shaft for any wear. Next, use the Tech1 to check for long-term fuel trim. Since block learn cells are arranged by engine RPM and map, it's critical that this be checked at the same RPM and load at which the chuggle condition occurs. Long-term fuel numbers can vary greatly between cells if a problem is occurring only under certain RPM and load conditions. If the reading is near 110 or 150, correct for a lean or rich condition. The service manual trouble trees for DTCs 44 or 45 can help to correct these conditions. Check for proper EGR and TCC operation using charts C7 and C8 from the service manual. It's also a good idea to monitor fuel pressure while the problem is occurring. Pressure should remain steady between 9 and 13 psi. The final step of this diagnostic approach is to check that the proper prom is installed. Don't forget to refer to the Know-How Reference Manual for the complete diagnostic approach to spark knock and chuggle conditions. Bill, why don't you take it from here?
Thanks, Chuck. During the last Know-How survey, quite a few of you indicated that you would lack some additional information on rough idle and miss conditions. I've developed a list of some things that may cause rough idle and misses. Most of these tips aren't published anywhere because they come straight from the field. Let's start with the first tip. After isolating a miss to a particular cylinder, use the ST125 to check for a good spark, and then perform the injector resistance test to see if the injector checks out. If both are okay, try swapping the injector to another cylinder. If the miss transfers to the other cylinder, the injector has an internal problem and should be replaced. The next tip on the chart is for 1993 5.7 liter engines with sag, hesitation, or rough idle conditions. If everything checks out during normal diagnosis, try replacing the ECM with a known good one. We've seen ECMs in these vehicles that have intermittent internal problems. Remember, it's important to run through the normal diagnosis before replacing the ECM. After driving several hundred miles, some 1992 5.7 liter engines may develop an intermittent miss that is felt under load. There is a simple cause for the miss, yet sometimes it's hard to find. This miss may be caused by the number 7 spark plug wire shorting out against the throttle cable bracket. You may want to use a spray bottle to check if the wire is shorting. If the wire is making contact, replace the wire and reroute it over the cable. Let's go on to the next step. It's for missed conditions on 1994 5.7 liter engines while under load doing heavy acceleration. This condition may be caused by a pinch wire between the cylinder head and the engine mount. It is likely that this condition is caused by the location of the number 3 wire loom. Reroute the wire if you see this condition. This next one is interesting. We've experienced some conditions where garage door openers don't work when they're in 1995 Roadmasters with the engine running. This condition is caused by a loose center ball in the epoxy coating of the A-bits distributor cap. This seems to cause interference with the garage door opener signal. If you see a vehicle with this condition, try turning the engine off, or try the garage door opener in another vehicle. If it works now, replace the distributor cap. On to the next tip. We've seen several 1991 to 93 Roadmasters that experience a condition where the tachometer needle appears to be moving like a quartz clock. Even though the original distributor cap may show no signs of damage, replacing the distributor cap seems to correct the condition. The next one is for 1992 5.7 liter engines. It covers intermittent stall conditions after extended highway driving of several hundred miles or more. The condition may occur at idle or at highway speeds. After stalling, the vehicle will be hard to start or may not start at all. Additional symptoms are that the fuel tank appears collapsed inward and the fuel gauge level may fluctuate. If these symptoms appear, try removing the fuel tank filler cap. If the engine restarts, there may be a restriction in the fuel ventilation system. Check the ventilation line for any restrictions or kinks. If the vent system looks okay, check the charcoal canister itself. Another possible stall problem also occurs after driving several hundred miles. There have been a few cases where a small amount of condensation leaks out of the HVAC case. The water eventually accumulates and makes its way into the ECM right here. If this condition is found, replace the ECM and then build a shield around the new ECM to protect it from future condensation buildup. The next tip on the chart is for 1994 engines that exhibit various drivability conditions such as rough idle, miss, hesitation, or surge. We've found that an internally leaking intake manifold may cause these conditions. To check for this condition, monitor bank 1 versus bank 2 long-term fuel trim reading. A significant difference between the right and left side indicates a leaking intake manifold gasket on the side with the high number. Another way to check for this condition is to start the engine and disconnect the PCV and fresh air intake hoses. I've already plugged off the PCV intake hose. Now check for vacuum at the fresh air intake hose. There should not be a vacuum pull unless the intake manifold is leaking. The next tip is for backfire, surge, or rough running conditions at engine speeds over 4,500 RPM on 1994 and 1995 engines. First, check that the PCM ground is properly tightened. If it is, check the coil wire. If the resistance is more than 30,000 ohms, replace it. Remember, the coil wire is serviced separately. Another thing to check for is a leaking EGR solenoid. A leaking solenoid allows vacuum to flow to the EGR valve and may cause it to open slightly. This would create a rough idle condition as well as a noticeable hesitation coming off idle. I'd like to mention one final tip. I've seen a few cases on 1994 engines where the A-bits ventilation hose clamp is contacting an ignition wire. Make sure that this clamp is not contacting any of the wires on the left side of the engine. If it is, reroute the wire or reposition the clamp. Most of the tips I've covered today only take a minute to check out. Be sure to go over them and refer to the technical tips section in the know-how reference manual when diagnosing these conditions. Dave, why don't you take it from here?
Thanks, Bill. I want to take this opportunity to answer some questions that were sent in from a recent know-how survey. But before I do that, I'd like to quickly mention several items in regards to the newer 5.7 liter P engine. Whereas fuel pressure on the earlier throttle body engines runs from 9 to 12 psi, this port-injected engine uses the 3-bar fuel pressure regulator typical of most later port fuel-injected engines we use. Fuel pressure should then read between 41 and 46 psi with the fuel pump running and the engine off, or when the engine is running and vacuum is removed from the pressure regulator. Depending upon engine vacuum then, actual fuel pressure while the engine is idling will be from 5 to 9 psi below this. Remember that fuel pressure regulator settings are most accurately checked with no vacuum to the regulator. And now on to the questions. Kim Lehman of Wallingford Buick asked, why do 1992 and 93 5.7 liter engines sometimes fail emission tests? This is a good one. Currently, engineering is developing a new calibration for this engine. The calibration we now use diverts air pump output into the atmosphere at idle. The new calibration will divert the air pump output to the exhaust manifold at idle. This additional airflow allows the catalytic converter to maintain a higher temperature, particularly during extended idle. This in turn improves the catalytic converter's efficiency in reducing hydrocarbons and carbon monoxide emissions. However, there are some tips that we currently use to get these throttle body engines to pass emissions tests. Before we go over these tips, let's review what unburned hydrocarbons and carbon monoxide represent and the factors that affect their level in engine exhaust. Unburned hydrocarbons are really nothing more than unburned fuel vapors in the exhaust. Therefore, the hydrocarbon reading will be excessive due to unburned fuel vapors making their way into the exhaust anytime all the fuel is not completely burned. An excessive HC reading could be caused by an air-fuel mixture that is either too lean or too rich, an ignition malfunction, or any mechanical engine problems such as burned or leaking valves that tend to promote misfiring of a cylinder or incomplete combustion. On the other hand, carbon monoxide is a direct representative of how much incomplete combustion is taking place due to the richness of the air-fuel mixture. In other words, carbon monoxide is directly proportionate to the richness of the air-fuel mixture. CO is created when there is not enough oxygen present to allow two oxygen atoms to combine with each carbon atom of the fuel. The richer the air-fuel mixture, the higher the CO reading will be. The leaner the air-fuel mixture, the lower the CO reading will be. Therefore, an overly rich air-fuel mixture will create high CO and high HC. If the air-fuel mixture is lean, CO will be low, but due to the difficulty in burning an overly lean mixture, HC will be higher than normal. Keep in mind that the purpose of the catalytic converter is to promote continued combustion in the exhaust through heat and chemical oxidation. This function serves to clean up those unburned hydrocarbons and carbon monoxide that are in the exhaust. If the catalytic converter has lost its efficiency, or if the air pump is not functioning as designed, higher than normal HC and CO will be present in the exhaust. There are a few things that I usually do when working on these older throttle body engines that don't pass emission tests. First, before doing anything, make sure that the vehicle was driven long enough before the emission test was performed. After driving, some customers may wait in line to have the emission test done. Oftentimes, this waiting period is long enough for the catalytic converter to cool down. Maintaining a fast idle while waiting in line will increase the converter's temperature. This will improve its efficiency and the vehicle's ability to pass the emission test. If this isn't the case, start off by checking the basics. Make sure that all the spark plugs are in good shape and that the wires are in good condition and properly routed. Use a Tech 1 to check if block learn and integrator readings appear normal. Engine coolant temperature is hot enough, and canister purge is functioning properly. Check injectors for signs of dripping or leakage. Engine oil for signs of fuel dilution and that initial timing is set correctly. Your shop's infrared exhaust analyzer can come in handy when verifying crankcase fuel dilution. Insert the analyzer probe into the oil fill opening to check for unburned hydrocarbons. Once you're certain that these things are okay, there are a few other things that can be done as well. Start off by using GM Top Engine Cleaner. Be sure to follow the instructions on the back of the can when performing this operation. The GM Top Engine Cleaner helps to clean the intake ports, intake valves, and upper cylinders of carbon and varnish buildup. By design, throttle body engines are more sensitive to carbon deposits in these areas. This is due to the fuel being mixed with the airflow as it enters the intake through the throttle body. The fuel must stay fully vaporized and suspended in the airflow as it is distributed to each cylinder. Port-injected engines are less affected by this condition since fuel is distributed directly to each intake port to mix with intake air. Another thing to check is the type and quality of fuel being used. Certain fuels can create gum and varnish deposits on intake valve neck and stem areas. These deposits can build up over time and lead to improper valve seating. This in turn increases the unburned hydrocarbon output. Using the top engine cleaner will also help remove these deposits. Let's go on to the next question. Dean Juliar of Bergstrom Buick writes, I seem to remember a distributor shaft magnetism test for Chevy trucks equipped with a 5.7 liter engines. Does Buick have a test for throttle body 5 liter and 5.7 liter engines as well? Yes, Buick does have a distributor shaft magnetism test. In fact, it's probably the same as the one for those Chevy trucks. To test the pole piece for a weak magnet, place the vehicle in bypass mode and verify initial timing. Once the timing is correct, slowly increase the engine speed while watching the timing mark. Most engines will begin to advance at around 2300 RPM. If timing doesn't begin to advance by 2600 RPM, the magnet in the rotating pole piece is weak. This test is actually looking for pickup coil output voltage to exceed a certain level. The ignition module contains a spark advance curve that is used for backup if EST fails while the vehicle is being driven. The module looks for pickup coil peak voltage to exceed a set value before this backup routine kicks in. As RPM increases, pickup coil output voltage will increase, thus providing a type of centrifugal advance. A weak timer core magnet can cause a stall at idle, particularly while under a load. You can also check for a weak timer core magnet with the distributor removed from the vehicle. While rotating the distributor shaft, you should feel the magnetic poles attract as they align on a good distributor. If you can't feel the poles align, the magnet is probably weak. There is also a good test procedure to check for proper alignment of the reluctor wheel on the distributor shaft. I've seen a few cases where the reluctor wheel has slipped or been mispositioned on the distributor shaft. If this is the case, ignition timing will still be correct, but an engine miss or cylinder crossfiring during certain RPM ranges will result due to rotor tip misalignment with the distributor cap. To check the rotor tip alignment, bump the engine over until the timer core teeth are aligned with a magnetic pickup. Install a cutaway distributor cap and check the alignment of the rotor tip to the terminal on the cap. It should be just at or past the trailing edge of the terminal. On to the next question. Tim Arthur of Century Buick asks about engine surge between 45 and 55 mile per hour from the TCC. Tim, I'm sure you're referring to chuggle. Chuck talked about repairing this condition in 92 and 93 throttle body engines. I would, however, like to address the 94 and 95 5.7 liter P engine. There's a repair coming for chuggle conditions when accelerating on slight grades or during light deceleration when going downhill. A calibration update is planned that will raise the engagement speed of the torque converter for chuggle conditions under light loads up to 54 miles per hour. A major contributor to deceleration chuggle while going downhill is the amount of EGR that is used. This will also be addressed with this new calibration. Here's another question. What types of problems have been experienced with A-bits? To this point, the A-bits ignition system has done quite well for us at Buick. However, one item that occasionally shows up is engine misfires due to moisture or contamination buildup inside the distributor. Here's an A-bits distributor cap that has been heavily corroded. Typically, these conditions are due to a restriction in the A-bits ventilation system. The ventilation system is responsible for removing harmful contaminants that collect in the distributor during normal operation. Air is directed from the snorkel through this hose to the base of the distributor. Note that the air intake is located downstream of the mass airflow sensor and air filter. This is so airflow entering the distributor is filtered and metered. Once inside the distributor, air flows through it and removes the contaminants. Vacuum from the intake manifold pulls the airflow then out of the distributor through this hose and then through a filter and a metering orifice into the intake manifold. It is critical to the proper operation of the A-bits distributor that the air snorkel, distributor assembly, and the intake manifold be flowing air correctly. Any restrictions or leaks will allow either moisture or corrosive contaminants to collect in the distributor. Now, let's go over an easy way to check the A-bits ventilation system for restrictions or leaks. Begin by checking the harness for pinches or kinks before testing. It is important to check the connection at the snorkel for any flashing or restriction. Flashing in the snorkel will not be checked in this procedure. Remove both of the vacuum connections from the distributor and then connect them together using a vacuum fitting. This must be done because the A-bits distributor is not designed to be airtight and will produce false results in the vent system tests. Remove the ventilation hose from the air snorkel and connect the hose to a vacuum gauge. Remove the ventilation line at the intake manifold and install a T-fitting into the hose. Install a second vacuum gauge to one end of the T and then install the other end back into the intake manifold. Now we're ready to test the harness. Make sure the vacuum gauges are clear from any moving components and then start the engine. Now I'll monitor both vacuum gauges while the engine idles. If the vacuum levels climb quickly together and then stop at the same value, the harness is functioning properly. This one looks good to me. If the ventilation harness is leaking, the vacuum levels will climb quickly for a short period of time. Note that the vacuum gauge at the intake manifold will achieve a slightly higher vacuum level than the one at the air snorkel. A difference in the two readings of over 1.5 inches of mercury is unacceptable, and the harness should be inspected for loose connections or holes. Also make sure the ventilation system is not leaking from the point where the two hoses are connected together for the test. If the ventilation harness is restricted, the vacuum level at the intake manifold gauge will climb faster than the one at the air snorkel. Eventually, the levels between the two gauges will even out. If it takes more than 5 seconds for the two gauges to equalize, it is unacceptable and the harness should be replaced. Now that we've covered misfires that can be caused by the ventilation system, I want to go over a few other things I've encountered with this system. Cross-tracking in the epoxy cover of the distributor cap can also cause misfire conditions. To test for this condition, remove the spark plug wire from the spark plug of the suspected cylinder. Now, check for resistance between this wire and the remaining 7 spark plug wires. The meter should read infinite for each wire. If you don't get this reading, replace the ABITS distributor cap and rotor. The cap and rotor are serviced together as a kit. One other thing that I've encountered is a miscondition on cylinder number 2. The cause of this is the spark plug wire terminal end breaking off at the plug. Replace the wire if the end is broken off.
Well, thanks for all the help, guys.
Thank you.
No problem, Chuck.
I've sure picked up a few good tips today. The things we've covered should really help when diagnosing Roadmasters with drivability conditions. And we'll see you all in the next Know How.